100 million years of evolution. The largest bivalve mollusk on Earth, living more than 140 years. And a billion-dollar market. The geoduck is the world's most expensive seafood delicacy, fetching up to $140 per pound in Hong Kong restaurants. But catching it isn't easy. It buries itself up to 3 feet deep and can outlive any fisherman. How are these unique giants farmed underwater? Why are Chinese millionaires willing to pay hundreds of dollars for a single clam? And what has turned the geoduck into a true symbol of luxury and status? Let's dive in. Geoducks are giant marine clams found along the Pacific coast, primarily near the western shores of North America. They are the largest of all bivalve mollusks, living more than 100 years, making them among the longest living creatures on Earth. Naturally occurring along the Pacific shoreline, indigenous peoples traditionally consumed them. However, global culinary fame came thanks to the Asian market, especially in China, Japan, and South Korea. In China, geoducks are prized as a delicacy, a status symbol, and even an aphrodisiac, partly due to their distinctive appearance. High prices, up to $140 per pound in Hong Kong restaurants, and limited wild populations have led to the creation of farms for artificial cultivation. An average geoduck weighs between 1 and 3 pounds, though some specimens can exceed 5 pounds. Thus, a large clam could cost anywhere from $300 to $700 or even more, depending on its size. Despite their unusual appearance, remember, it's a long, fleshy siphon protruding from the shell, they have tender, slightly sweet meat with a distinct oceanic taste. Geoducks are eaten raw, fried, boiled, or added to soups. Interestingly, China has the highest demand, though geoducks aren't naturally found there. Consequently, China actively imports geoducks from the United States and Canada and develops its own farms along coastal regions. Geoduck clam farming, especially in specialized underground farms, is among the most secretive and luxurious agricultural practices worldwide. China, with its rich maritime traditions, not only farms clams in open water, but has also developed unique underground farm methods for growing the most valuable mollusks. These farms feature specially constructed geoducks, large underground spaces providing perfect conditions for clam growth. Let's take a closer look at how exactly the world's most expensive clams are farmed and why this method is so unique. These farms differ from ordinary aquaculture setups in that clams aren't simply grown in water, but in specially prepared cavities, replicating the natural underground aquatic environment. They ensure stable conditions, crucial for clam quality and rarity. Optimal conditions are maintained precisely: water temperature, oxygen levels, salinity, and other factors. The natural environment created within these geoducks significantly enhances clam meat quality. A geoduck farm is quite unusual, resembling an underwater garden more than a traditional fish farm. Clam farms are located in shallow coastal areas at depths from 10 to 30 feet, typically in calm bays or coves. At the ocean floor, you can see thousands of vertically placed tubes, around 4 to 6 inches in diameter and 12 to 18 inches long. They look like vast plantations of tubes sticking out of the sand. These tubes protect young geoducks. Without them, predators like crabs, sea stars, fish, and seagulls quickly consume the mollusks. Tubes are needed only during the first few years. Tiny geoduck larvae float in the water for several weeks before settling onto the seabed and burrowing into the sand. That's when farmers place them into tubes. The geoduck grows in the sand, not inside the tube itself. The tube merely protects it until it becomes large enough. After 2 or 3 years, the tubes are removed. By then, geoducks have burrowed deeply, up to 3 feet, making it challenging for predators to reach them. Nets are often stretched above the tubes to prevent attacks from birds and other predators. Buoys at the surface mark farm locations and provide diver and worker access. A farm can span several underwater acres, with only small maintenance structures visible from shore. On land, there are specialized tanks for sorting and cleaning clams before sale. Thanks to natural underground caves and artificially created tanks, geoduck farms significantly enhance clam growing conditions. A key factor distinguishing these farms is temperature and humidity stability. Constant monitoring of these parameters allows farms to achieve ideal growth conditions. Additionally, underground farms minimize external environmental impacts, such as water pollution, a significant issue for conventional aquaculture. Underground farms can also be located in areas naturally conducive to clam cultivation, creating the most stable possible conditions for mollusk growth. Geoducks grow 5 to 7 years before harvesting. But what do farmers do during this growth period? They don't just wait, they carry out several crucial tasks. During the first years, farmers monitor tubes, checking for blockages caused by sand or algae. They protect clams from predators such as crabs, sea stars, fish, and birds that might enter the tubes. They also monitor sediment levels and water quality since geoducks are highly sensitive to pollution. Periodically, farmers selectively retrieve clams to check their size and condition, determining the optimal harvest time. Farms operate continuously. While one batch grows, farmers introduce new larvae. Every year, thousands of larvae are planted to maintain a steady harvest. To harvest clams, farmers come during low tide, when water recedes and sand is easier to dig. On the surface, 2 holes in the sand indicate the geoduck's siphon, through which it filters water. Farmers use special water pumps that spray high-pressure streams into the sand, loosening it. The farmer carefully retrieves the geoduck by hand, avoiding damage to its long siphon, highly valued in restaurants. Clams are then washed, chilled, and shipped alive to restaurants. Underground farms also minimize environmental impact, significantly reducing risks of water or ecosystem contamination compared to traditional open water farming methods. Moreover, these farms ensure continuous clam supply, despite weather or water level fluctuations. Geoducks can live over 140 years, making them among the longest living bivalve mollusks. Their age is determined by shell rings, similar to tree rings. They date back over 100 million years, existing during dinosaur times. Belonging to the Hyatellidae family from the Cretaceous period, these clams have changed little over millions of years, making them living fossils. Their survival strategy, burying deeply and filtering water, proved so effective evolution didn't require significant adaptation to new conditions. Interestingly, their ancient relatives were much smaller, while today's giant siphon evolved to allow deeper ocean floor burrowing, helping avoid predators. Unlike most animals, geoducks remain reproductively active throughout their lives. A female can release 5 million eggs in a single season. This and their shape have led to aphrodisiac myths, though scientific evidence is scarce. However, they contain high zinc levels, essential for testosterone production and reproductive health, as well as proteins, amino acids, and micronutrients beneficial for overall energy and wellness. Geoducks are spawning mollusks with external fertilization. Females and males release eggs and sperm simultaneously into the water, synchronizing reproduction and maximizing fertilization success. Fertilized eggs develop in the water, with larvae passing through several stages before settling on the bottom, anchoring themselves with their foot to suitable places, such as tubes or sandy ground. Settled larvae gradually mature into adult geoducks, reaching reproductive maturity within 5 to 7 years, crucial for farm harvesting. Farmers source geoducks in several ways, initially collecting wild clams capable of reproduction or purchasing juvenile clams from specialized hatcheries or companies. This allows quicker production startup without waiting for clams to mature. Some farmers reproduce clam populations independently through incubation and breeding stimulation. Naturally, farmers facilitate reproduction by ensuring optimal conditions. Due to the thick siphon skin, geoducks retain moisture and stay alive up to 5 days after harvesting, allowing frequent sales as fresh products. Every minute, more than 55 short tons of whey protein are produced worldwide. But just a few decades ago, people would simply pour out this liquid, not realizing it held one of the purest sources of protein. Today, it is a multi-billion-dollar industry where ordinary whey from milk undergoes a high-tech journey of filtration, drying, and packaging before ending up in your sports shake. How did this ordinary byproduct of the dairy industry become the foundation of sports nutrition? Let us figure it out. The cycle begins with choosing high-quality raw materials. Do you know what whey is, if we are not talking about vaccines? When milk is used to make cheese or yogurt, it separates into two parts: the solid curd that becomes cheese, and the liquid whey, which was thrown away or used as animal feed several decades ago. However, people discovered that this liquid is full of valuable proteins, so it is now filtered, dried, and transformed into powder, the same whey protein you find on store shelves. When milk curdles, only 10 or 20% of it turns into cheese, while the remaining 80 or 90% is whey. Most large protein producers work directly with farms located near their factories to secure a steady supply of this raw material. In the United States of America and Europe, whey often comes from large dairy farms. In Australia and New Zealand, it is commonly sourced from traditional pasture-based farms, where cows eat natural grass. The quality of the protein depends on the quality of the milk, and that quality is influenced by how cows are raised. This is why some brands emphasize that their whey protein is from grass-fed cows, without antibiotics or hormones, and from certified dairy farms. The type of final product also depends on the milk's fat content. If the milk is used to produce a full-fat cheese, such as cheddar or Gouda, the resulting whey has less fat and is more suitable for making a pure protein powder. If it is a lower-fat cheese or cultured dairy product, the whey may contain more lactose, which affects the flavor and overall quality of the final powder. Many whey protein manufacturers prefer whey from hard cheeses because it typically has a higher concentration of pure protein and fewer byproducts. To make about 2 pounds of cheese, you need approximately 2½ gallons of milk, and the rest of that milk turns into liquid whey, which can be used to obtain protein. Whey protein naturally contains very little fat, since most of the fat stays in the cheese. The whey that will be turned into protein is transported to factories in special sealed containers or tankers. Because whey is a liquid that spoils quickly, it must be delivered at low temperatures to maintain its quality. Once whey is collected from the milk, it is cooled to around 39 degrees Fahrenheit to reduce the risk of bacterial growth. For transport, specialized insulated tankers or trucks with refrigerated compartments are used. These vehicles can maintain a constant temperature to keep the whey fresh during the trip. Transport containers are typically airtight to prevent air from spoiling the whey and to preserve its quality. After delivery, the whey is usually tested to ensure it meets the standards required for further processing into protein. This transport system guarantees that the whey arrives at the factory with its beneficial properties intact and is ready for the next steps of protein powder production. Once the whey reaches the plant, it is carefully transferred from the tankers into large, specialized reservoirs. These are often stainless steel vats or other containers that keep the liquid hygienic. If the whey has not yet been cooled to the ideal temperature, it undergoes additional chilling to prevent bacterial growth and to provide optimal conditions for the next manufacturing stages. At this stage, the whey may pass through filters to remove any foreign particles or unwanted impurities. This step is crucial to avoid quality issues later in the protein production process. Often, the whey is first concentrated by removing some of the water through ultrafiltration or other techniques, which increases the protein content. In certain cases, the whey may be heated to activate specific enzymes or prepare it for subsequent processes, thereby improving the efficiency of protein extraction. Protein, also called a protein molecule, is an organic compound composed of amino acids linked by peptide bonds. It is a major building block of the cells in living organisms and performs numerous vital functions within the body. Proteins play a key role in forming tissues, cells, and organs, as well as in driving various processes essential for an organism's life activities. They are the main components of cells and tissues. Proteins create structures like muscles, skin, hair, nails, organs, and other tissues. Many enzymes are proteins that speed up chemical reactions in the body, including food breakdown, energy production, and other important biochemical functions. Proteins are involved in the transport of molecules and ions in the body, such as hemoglobin, which carries oxygen in the blood. They also regulate various biological processes, including growth and development, and support the body's immune defenses in the form of antibodies. Although supplying energy is not the primary role of protein, the body can use it as an energy source when necessary, especially if carbohydrates and fats are in short supply. Proteins consist of 20 main amino acids, 9 of which are essential, meaning the human body cannot produce them, and they must come from food. Animal products like meat, fish, milk, and eggs contain all the essential amino acids, making them complete protein sources. Membrane filtration is a critical step in processing whey for protein powder production. It allows an efficient separation of the beneficial protein from less useful components, such as lactose, fats, and minerals. This procedure employs special filtration membranes with microscopic pores, functioning like extremely fine sieves that only allow molecules of certain sizes, including proteins, to pass through. 3 main types of membranes are typically used for membrane filtration: ultrafiltration, nanofiltration, and reverse osmosis. In the first stage, membranes with larger pores let water, lactose, and minerals pass through, while holding back larger protein molecules. Nanofiltration membranes have smaller pores, allowing only smaller molecules such as minerals to pass, while retaining bigger protein molecules. The final step, often referred to simply as osmosis in a reverse osmosis system, helps remove water and small molecules like lactose, resulting in a concentrated protein. Once the whey enters the membrane system, it is pushed through the membranes under pressure. The portion of the liquid that contains dissolved substances such as water, lactose, and minerals passes through the membrane, while larger protein molecules remain on the membrane's surface. This approach yields a more concentrated protein. After membrane filtration, the whey is divided into 2 streams. One contains the larger protein molecules, the concentrated protein, which will be further refined into protein powder. The other includes lactose, minerals, and water, and may be discarded or used for other food or industrial purposes. This process can be repeated multiple times to further boost protein concentration, resulting in protein concentrate or protein isolate, which differ in their levels of purity. Following membrane filtration, once the whey has reached a high protein concentration, the next step is drying. This is crucial because it transforms the liquid concentrate into a powdered form that is easy to store, transport, and use. One of the most widespread methods involves exposing the whey concentrate to a stream of heated air, which evaporates the moisture and leaves behind powder. This approach is sometimes referred to as hot air drying, or a form of air-based microfiltration, and it is commonly used to produce powders with a high protein content. In the case of rotary dryers, the whey concentrate is dispensed onto rapidly rotating drums heated by hot air, causing the moisture to evaporate. Another frequently used technique is spray drying, where the whey is sprayed into fine droplets in a chamber that circulates hot air. The droplets quickly lose moisture, forming small particles of powder that readily dissolve in water. During drying, it is crucial to control the temperature, because very high temperatures could damage protein molecules or compromise the final product's quality. Typically, the temperature does not exceed 175 degrees Fahrenheit in order to retain all of the protein's beneficial properties. After this step, the whey becomes a powder with a moisture content of less than 5%. The powder is then stored in sealed packages to prevent it from absorbing moisture from the air. That is all there is to it. The only remaining task is to package the finished protein. Modern factories use high-speed packaging lines. For example, a single automated line can fill up to 40 packages per minute. Over one day, it can pack around 50,000 packages of protein powder, which usually totals 2 or 3 short tons of finished product. The packaging process is completely automated. Powder travels directly from a container or hopper into packaging machines that automatically fill each package with gram-level accuracy, ensuring precise dosing. Packaging machines operate not only at high speed, but also with great precision. They can include sealed closure systems to prevent air and moisture from entering, which helps the product remain fresh. An automated system inspects every package to detect any defects, such as incomplete sealing, and discards flawed packages. Once the protein powder is packed, the packages may be automatically marked, labeled, and moved onto a conveyor for further boxing or palletizing for shipment. These machines are capable of packing up to 1,000 packages per hour into a single box, guaranteeing rapid and efficient delivery of the final product to consumers around the world. Imagine this. Every year, more than 50 million drums are made around the world. But have you ever wondered how a piece of wood becomes a powerful instrument that sets the rhythm for music? From ancient shamanic rituals to modern rock arenas, drums have always been the heart of sound. To create the perfect drum, wood is dried for years, metal parts are crafted with jewelry-like precision, and membranes undergo special treatments. Today, we're going inside this process, step by step, from the lumber mill right onto the stage. The drum is one of the oldest musical instruments in the world. Its history stretches back at least 7,000 years, perhaps even more. The earliest drums were simple, animal skins stretched over wooden or clay bases. Over time, they evolved into the complex structures made from various materials that we see today. The oldest drums found by archaeologists date back to 5,000 years before Christ. They have been discovered in Africa, Mesopotamia, China, and Egypt. These early drums featured clay or wooden bodies with animal skin membranes stretched with ropes or glued on with resin. In shamanic rituals and religious ceremonies, drums were used to communicate with spirits. In ancient China and Egypt, drums coordinated armies on battlefields. In some African tribes, drums were even used to send messages over long distances. In the Middle Ages, drums became popular in Europe thanks to the Arabs, who brought them through Spain during the Muslim conquests. During this period, drums became integral to military music and later orchestras. A drum isn't just a chunk of wood or metal. Every part matters: the shell, the membrane, the hoops, bolts, and even the drumsticks. All these elements are crafted from carefully selected materials, and each affects how the instrument sounds. Wood used for drum shells must be properly dried, processed, assembled, and finished with lacquer. Metal parts are cast, polished, and protected against corrosion. The process is more complex than it first appears. Let's dive deeper into these details. Wooden drums have a special warmth to their sound. But as we said before, creating such a shell first requires carefully selecting, preparing, and drying the wood. The most popular choice for drum shells is maple. It produces a warm, balanced tone with excellent lows, mids, and highs, making it a staple in most studio and live drums. Birch provides a bright, aggressive sound, boosting the highs and lows, perfect for rock, metal, and live performances. Mahogany offers a deep, bass-rich sound with mellow highs, famously used in vintage drums from the 1950s and 1960s. Bobinga, a dense African hardwood, delivers a darker, powerful tone with great attack. More expensive, it's reserved for premium models. Oak, harder than maple, provides an exceptionally loud, penetrating sound ideal for live settings. Simply cutting down a tree and slicing it into boards is just the beginning. The tree must be harvested in a specific season, usually winter, when it contains the least moisture. Logs without cracks or knots are chosen. Freshly cut wood can have up to 60% moisture. First, the wood air dries outdoors for several months or even years. Then it undergoes kiln drying, reducing moisture content to between 8 and 12%. Next, boards are sliced into thin layers called plies, glued together under high pressure. The thickness of these wooden plies typically ranges from 0.024 inches to 0.118 inches. To produce uniform, thin layers without excess waste, several methods are used. Rotary cutting involves mounting logs onto special machines that spin them while blades peel thin, continuous wood strips, typically for budget drums. Bandsawing uses a flexible, continuous saw blade, moving in a loop to cut logs into thin plies. This method provides more precise cuts than rotary peeling, and preserves the wood grain better, although it creates more waste. For high-end drums showcasing exotic wood grains, manufacturers employ veneer slicing. Logs or boards are fixed, then moved against a sharp blade to shave off thin sheets. Laser cutting is the least common method. premium drums sometimes feature solid wood shells, providing unique tonal qualities. But today, we're not focusing on those. Let us know in the comments if you'd like a separate video dedicated to that topic. First, the plies are coated with special glue, then stacked, forming a multi-layered structure. The number of layers typically varies from 4 to 20, depending on the desired shell thickness. Next, this stack is placed into specialized molds, bending the wood into a perfectly round cylinder. Even pressure is crucial to prevent defects and air bubbles in the glue. Afterward, the shells dry for several hours or even days. Once the glue hardens, shells are removed, edges trimmed, sanded, and drilled for hardware. This method is economical and allows manufacturers to experiment with combinations of wood types to influence sound characteristics. Polishing and applying finishing coatings is primarily manual work, especially for high-quality or custom drums. Shell surfaces are carefully sanded, removing all irregularities. Sanding happens either by hand or machine, progressing from coarse to extremely fine abrasives, usually from 120 to 400 grit. For glossy lacquer finishes, manufacturers may first apply primer to prevent excessive absorption by wood pores. Oil or wax finishes are rubbed in manually using soft cloths or brushes, penetrating deeply into the wood pores, protecting from moisture and enhancing the natural color. Lacquer is sprayed in several thin layers, drying completely between each coat. This process is performed by skilled artisans manually or by automated equipment in large factories. After drying, shells receive a final polishing to achieve the desired gloss, ranging from matte to mirror-like shine. In large companies like Pearl or Yamaha, producing hundreds of drums, lacquer is applied automatically. Still, final finishing always occurs by hand, since even the best machines cannot match human precision. Boutique manufacturers such as Cravioto, Brady, or Noble & Cooley finish every shell entirely by hand, making each drum unique and even more expensive. Even wooden drum shells have numerous metal parts: hoops, tension rods, and grommets. Hoops are typically chrome-plated steel, brass, aluminum, or even wood. Tension rods are commonly stainless steel or brass. Grommets are small metal inserts reinforcing the drilled holes in the shell. How are metal parts produced? Metal is melted at high temperatures, then cast or machined into required shapes. These parts are sanded and polished, removing roughness, then coated with protective layers like chrome or nickel to prevent rust. Historically, drums featured animal skins: cow, goat, or buffalo. Nowadays, synthetic plastics are more common due to their stability, durability, and weather resistance. Natural animal skin, being organic, expands and contracts with humidity and temperature changes. Moisture makes skins softer and sounds duller, whereas dry conditions cause them to shrink and crack. Synthetic materials maintain consistent tension regardless of weather. Once tuned, synthetic drumheads remain stable until manually adjusted. Drumhead materials, whether skins or plastic, are cut into circular pieces, treated chemically for flexibility, then pressed and stretched onto metal hoops. Preparing animal skins is truly spectacular. Inside large workshops, air smells of smoke, salt, and something sharp. Huge wooden vats line the walls, holding pieces of skin that visibly change color. This isn't mere soaking. It's true alchemy transforming tough, uneven hides into perfect drumheads. Initially, skins soak in large vats containing lime solutions, softening them and removing hair. After several hours or days, skins become lighter but still coarse. Next, they're treated with tanning substances, penetrating their structure on a molecular level. Vats emit steam. The aromas of wood, metal, and rawhide blend in the air. To avoid excessive stiffness, skins are stretched onto large wooden frames. Craftsmen stretch the skins manually, feeling thickness with their fingers. Sometimes steam is used, filling the workshop with thick vapor as skins are warmed before final treatment. Lastly, skins are rubbed with special mixtures: oils, waxes, sometimes herbal extracts. This keeps them flexible yet strong. In some regions, they're even smoked, imparting a light, smoky scent and improved water resistance. Even the best drum won't sound great without proper drumsticks. These are also crafted from carefully selected wood. Wood, typically hickory, maple, or oak, is sawn into blanks and air-dried naturally. But this takes time, so kilns usually speed the process, carefully controlling temperature and humidity, aiming for moisture content of 6 to 8%. Correct moisture levels are critical. Too moist, sticks warp. Too dry, they become brittle. Dried blanks are shaped on high-speed lathes. Each stick must have identical diameters. Otherwise, sticks within pairs produce different sounds. Simply turning a round stick isn't enough. Tip shape, taper in the middle, and weight distribution define how sticks sound when striking drums. High-speed lathes achieve precision within thousandths of an inch to ensure consistent quality. Every single year, more than 20 million short tons of dairy products are produced worldwide, and Nestlé condensed milk takes a significant portion of that total. Just imagine this. Each day, over 100,000 gallons of milk arrive at the company's factories. But even the freshest milk still shows up dirty. Yes, indeed, microscopic particles of dust, feed, and even traces of blood can make their way inside. How do they turn all that into perfectly smooth, thick condensed milk that melts in your mouth? And why would it be a completely different product without those tiny lactose crystals? Watch until the very end. You will not believe what every drop goes through. Today, Nestlé is one of the leading global companies in the food industry, and its products, including condensed milk, are represented in many markets around the world. It all started in the year 1866, when the Anglo-Swiss Condensed Milk Company was founded, becoming the very first to produce condensed milk in Europe. Meanwhile, in the year 1867, the Swiss pharmacist Henri Nestlé developed the first infant milk formula, which marked the beginning of the Nestlé brand. Nestlé began producing condensed milk in the 1870s, entering into direct competition with Anglo-Swiss. However, in the year 1905, the two companies united, forming one large corporation called Nestlé and Anglo-Swiss Condensed Milk Company. This move provided the impetus for rapid development of condensed milk production and export all over the world. Initially, condensed milk was positioned as a nutritious and long-lasting product that could replace fresh milk, especially in regions with limited access to high-quality dairy. Because of its prolonged shelf life and ease of transportation, it quickly gained popularity, not only among military personnel and travelers, but also in everyday family life. In the United States of America, Nestlé began its active condensed milk production at the start of the 20th century, constructing its factories and expanding its market presence. Over time, the brand came to be associated with high quality, and Nestlé condensed milk became an integral part of culinary culture, especially in desserts, baked goods, and coffee beverages. Today, Nestlé continues to produce condensed milk under different brand names, supplying markets in the United States of America and worldwide with products that combine tradition and modern standards of quality. The milk that is delivered to Nestlé factories is subject to extremely strict requirements. The company adheres to international quality and safety standards to guarantee the production of flawless products. Milk is supplied from verified dairy farms, where cows receive balanced nutrition and veterinary care. Before being sent to the factory, the milk undergoes its initial quality tests right there on the farm. The level of fat, protein, and the absence of antibiotics or other unwanted impurities are checked. Milk is transported in special refrigerated stainless steel tanks. The temperature during transportation is maintained at approximately 39 degrees Fahrenheit to preserve freshness and prevent bacterial growth. These tanks are sealed and regularly disinfected to ensure the highest standards of hygiene are upheld. Every day, around 100,000 gallons of milk arrive at Nestlé factories. Once the milk reaches the factory, it is tested again in the laboratory. Only then does it go into the main production process. The milk that makes the cut is fresh, safe, and of the finest quality. Precisely what becomes the foundation for the legendary Nestlé condensed milk. But how does it become so exceptional? An interesting fact is that no matter how perfect the process might be, the milk inevitably arrives at the factory dirty. As surprising as it may sound, the milk can contain microscopic particles that end up there during milking or transportation. These may be small leftovers of feed, dust, tiny bits of dirt from milking equipment, or other undesirable elements that are invisible to the naked eye. It is totally normal, since milk is a natural product, and these microscopic contaminants may appear during milking or storage. Cleaning and filtration are essential steps at the factory, which make the milk cleaner and safer for consumption by removing such particles. After the milk arrives, it first passes through filters that trap larger particles like hair, bits of feed, dust, or any other visible impurities. This is the primary step in getting rid of coarse debris. Next, the milk may go through a centrifuge. During this process, the milk spins at high speed, and due to centrifugal force, heavier particles like fat, impurities, or even traces of blood that might have entered the milk during milking are separated. You might wonder where blood could come from. I will explain. In a cow's body, blood is what transforms into milk in a complex biological process. Plus, an animal can have minor scrapes. Centrifugation also allows for standardizing the milk's fat content, if necessary, depending on whether high-fat or low-fat milk is being produced. The next phase is microfiltration. This is a finer filtration method that uses special membranes to remove small particles and microorganisms. It helps ensure even greater purity of the milk, which is crucial for the safety of the final product. After filtration, the milk is cooled to a low temperature, around 40 degrees Fahrenheit, to maintain freshness until further processing steps, such as pasteurization. Initially, the cleaned and cooled milk is temporarily stored in large, sterile stainless steel tanks. The pasteurization process at large factories like Nestlé is fully automated. When pasteurization begins, the milk flows from the tanks to the pasteurization units through sealed pipes. These pipes are made of stainless steel, which eliminates the possibility of contaminating the milk during transfer. Before entering the pasteurization apparatus, the milk may once again pass through filters for additional removal of any small particles that might still be present. The milk is pumped through the system by pumps that regulate both pressure and flow rate, ensuring a smooth, continuous process. The milk goes directly into a plate or tubular heat exchanger, which is a specialized piece of equipment that rapidly raises the milk to the necessary pasteurization temperature. The tubes or plates are heated by hot water or steam, and as the milk passes through them, it is heated to the required temperature, for example around 167 degrees Fahrenheit. In enormous silver-colored stainless steel tanks that resemble giant gleaming columns, fresh pasteurized milk is stored. Through a network of intertwining pipes, which seem almost like steel veins, the milk travels to separators, machines that rotate at extremely high speed, creating a fascinating visual effect. Inside these machines, the milk is separated into cream and skim milk under the influence of tremendous centrifugal force, which is difficult even to imagine. The large storage tanks at factories like Nestlé can hold anywhere from 5,000 to 50,000 gallons of milk, depending on the scale of production. The most common tanks have a capacity of about 30,000 gallons. On special display screens, digital readouts show the fat content, density, and temperature. Everything is under strict control. Robotic arms measure the exact amount of cream, blending it with skim milk to achieve the perfect balance. This step is reminiscent of how an artist carefully selects just the right shades of paint for a canvas. This is milk standardization. The process is automated and appears almost futuristic. Pipes carrying the milk, immaculate cleanliness, the hum of high-speed machines, and precision down to the thousandths of an ounce. The standardized milk comes out of the system, prepared for the next steps. To make sweet condensed milk, they add sugar, which can be around 40 or 45% of the mixture. Sugar here does more than just sweeten, it also acts as a preservative, helping the product last longer. The primary stage is removing excess water. The milk and sugar mixture is fed into vacuum evaporation systems, where, under reduced pressure, the blend is heated to approximately 150 degrees Fahrenheit. Thanks to the vacuum, the water evaporates quickly without scorching the milk. The outcome is a thicker mass with a significantly lower water content, about 30% instead of 87%, which is found in ordinary milk. After evaporation, this milk mass is still very hot and extremely thick. It is transferred to special cooling tanks, where cold water or a cooling fluid circulates along the walls. These are huge metal containers through which a chill seeps, almost like a gentle winter breeze. Large paddles, similar to giant mixers, slowly stir the milk, turning smoothly and steadily, so the mass does not settle or stick to the walls. The process is slightly like making ice cream. The hot mixture gradually cools down to about 90 degrees Fahrenheit. When the temperature reaches the right point, lactose crystals, milk sugar, are introduced into the mixture. These tiny, almost imperceptible particles act as seeds for the formation of thousands upon thousands of microscopic crystals in the milk mass. The milk continues to be gently stirred, and the crystals begin to grow in a very uniform way, thanks to precise temperature control and carefully managed stirring speed. If this process is disrupted, the crystals become too large, and then the condensed milk would end up grainy rather than smooth and creamy in texture. At the end of this process, the condensed milk attains the smooth, thick consistency, with a slight sheen that we all recognize. The result of perfect cooling and the meticulous handling of lactose crystals. In this way, from the chaotic ocean of hot milk emerges the sweet and tender product we know as condensed milk. Before packaging, the condensed milk is filtered one more time to remove any possible remaining unwanted particles and is tested for compliance with the standards. The finished condensed milk is packaged into cans, tubes, or pouches in aseptic conditions, sealed tightly, and then sent for cooling. Afterward, the product is ready for storage and distribution. Every single year in the United States, millions of cucumbers are pickled, and it is truly an artistic process. Have you ever stopped to think about how exactly that happens? All those jars of cucumbers lining the supermarket shelves, from the very first to the very last, have been harvested, processed, packed, and delivered, so they can end up right in your hands. So, let us peek behind the scenes together and discover how a full-cycle plant carries out this remarkable process. In the United States, some pickling plants operate their own plantations, where cucumbers are grown specifically for this purpose. It is not just about harvesting, it is also about ensuring that each cucumber has the perfect size and shape. This is no accident. Every cucumber that arrives at the plant must meet strict standards, or the pickling will not be as effective. For example, in the state of Michigan, which is home to one of the largest cucumber pickling companies, the plantation area can span 5,000 or even 10,000 acres. This allows for the cultivation of millions of cucumbers every year. Plants that specialize in pickling handle enormous production volumes. A single plant can process up to 100 million pounds of cucumbers per year. The exact amount depends on the size of the facility and the region. In order to maintain a stable supply to the market, these plantations often have contracts with farmers who grow cucumbers specifically for pickling. Ultimately, from harvest through processing, everything revolves around massive scale. These cucumbers typically measure from about 3 to about 5 inches in length, and their shape must be smooth, without bends or defects. This is important, since crooked or overly large cucumbers will not only look unappealing on store shelves, but can also harm other produce during processing, affecting the overall shelf life. Various technologies are employed on these plantations to ensure uniform cucumber size. For instance, they rely on controlled growing conditions, proper temperature, irrigation, and fertilizers, and row-based planting to avoid excessive competition among the plants. Additionally, automated sorting systems examine each cucumber to confirm it meets the required standards. This makes it possible to remove all imperfect specimens before they ever make it to the pickling stage. Full-cycle pickling plants are not just simple production sites where someone takes a jar and fills it with cucumbers. Rather, they are large-scale complexes in which everything, from gathering the cucumbers, through cleaning them, to packaging and labeling, is done under one roof. Picture vast areas that include not only production lines, but also specialized storage chambers for fresh vegetables, which must remain in pristine condition right up to the moment of pickling. Furthermore, such plants usually have laboratories to monitor product quality at every step. Hence, even when you buy a jar of cucumbers, you can be sure the production process has undergone rigorous scrutiny. As you can see, it is more than just a jar on a shelf. It is the end result of an entire industry that works at every level. The process of harvesting cucumbers on these specialized plantations is quite a spectacle, bringing together manual work and high-level technology. Initially, workers go into the field with baskets or special containers for collecting cucumbers. It is a delicate job because every single cucumber must be plucked by hand so the other plants are not damaged. In the past, harvesting was almost entirely manual, but as technology has advanced, more mechanical methods have been introduced. Nonetheless, workers still check each piece for ripeness and shape. On larger plantations, machines are frequently used to gather cucumbers. These machines feature special drums or vibratory mechanisms designed to collect the cucumbers without harming them. They move along the rows, carefully picking the produce. Although mechanical harvesting is faster, it requires constant supervision to minimize damage. Once harvested, the cucumbers often undergo an initial inspection right in the field. This might include basic sorting by size and shape, filtering out any cucumbers that fail to meet the standards for pickling. Certain plantations use automated systems to do this sorting. Immediately after harvest, cucumbers are transported to the plant for further processing, so their freshness is preserved. All of these steps are carried out very quickly, minimizing the time between picking and processing. Plantations often employ refrigerated trucks to keep the cucumbers from overheating. Now comes the most fascinating part. How exactly do cucumbers land in jars? It begins with washing and sorting. After harvest, cucumbers are thoroughly washed and checked for defects. The washing tanks can hold from about 11 to about 17 short tons of cucumbers at any one time, which is like a whole pool filled with these crispy green fruits. Often, long stainless steel baths are used, where the cucumbers travel along a conveyor belt fully immersed in water. They are first placed in a large water tank for soaking, which loosens soil and leaves. Air bubbles are introduced into the water to gently shake the cucumbers, removing dirt in a way that mimics the gentle motion of a natural stream. This helps avoid mechanical damage. Following the soak, cucumbers pass under strong shower units that rinse away any remaining residue. The water pressure is high, yet carefully managed so the delicate surface of the cucumbers is not harmed. Afterward, they roll across rows of soft rotating brushes, which remove any fine bits of dirt and give the cucumbers a clean, market-ready appearance. Clean cucumbers undergo a final check. Either cameras or employees examine their condition, looking for any defects, rot, or damage. The water used for washing is circulated through multiple rounds of purification and filtration. Many plants feature systems for reusing water, thereby reducing environmental impact. Only the best cucumbers move on to the next stage: slicing, pickling, and packing into jars. The pickling solution is not merely vinegar mixed with water. It is a carefully formulated combination of various spices, salt, and sugar that yields the cucumber's distinctive taste. Here too, there are secrets. The solution is prepared according to an exact formula specifying the precise amount of each ingredient. Following the washing stage, cucumbers travel by conveyor belt toward the slicing machines. Before slicing, they pass through a laser scanning system that measures their length and shape, ensuring uniform pieces. The slicing itself is performed by rotating stainless steel blades that spin at more than 300 revolutions per minute. The machine can be set for different slicing styles: rounds, strips, or halves, depending on the type of pickles being produced. In 1 minute, a single line can slice and prepare for pickling over 1,100 pounds of cucumbers. The cucumbers then proceed into a large tank, where they are evenly bathed in a hot pickling solution. The makeup of this solution can vary, but it generally includes water, vinegar, salt, sugar, and spices. Special nozzles guarantee thorough distribution of the liquid among all the cucumbers. The cucumbers advance to a specialized conveyor system where robotic manipulators precisely fill each jar. The nozzles measure out the exact amount of pickling solution for every jar. In the final stage, jars pass beneath a presser, which applies lids and hermetically seals them. One production line can handle up to 300 jars per minute. The accuracy of dispensing the pickling solution is calibrated down to the milliliter, ensuring no jar is overfilled. The pickling solution is drawn from dedicated reservoirs through a network of pipes that maintain a constant temperature of around 200 degrees Fahrenheit, thereby sterilizing the jars and prolonging shelf life. Any leftover solution returns to the reservoirs for reuse, which reduces costs. After each recipe change, the equipment automatically undergoes a hot water and steam rinse, ensuring everything remains pristine. Lids come in from a dedicated feeder system, where they are oriented and sent out precisely in sync with the jars on the conveyor. The lids are pressed firmly onto the top of each jar so that an airtight seal is achieved. The lid temperature can be kept at up to about 160 degrees Fahrenheit to aid in forming a secure seal. Sealed jars then move on to a separate conveyor, where labeling is done automatically. 600 labels can be applied per minute. Laser or thermal inkjet printers mark the expiration date and batch number directly on the label or lid. Cameras check label quality, and if any jar has a crooked or missing label, it is automatically diverted for another labeling cycle. In a single 8-hour shift, the plant can seal and label over 192,000 jars. Why are these pickles so delicious and always fresh tasting? Here is the key. Every step, from selection and growing to processing and packaging, is focused on preserving the natural taste of the cucumber while making the product both safe and flavorful for you. Everything is conducted in a manner that ensures efficiency and upholds the strictest quality standards. Thus, in this process, which is driven not only by technological innovation, but also by genuine passion and skill, you can witness true artistry. Each step, from planting the cucumbers to pickling them, deserves special attention. Indeed, even the way the jar looks on the shelf stems from the dedicated work of many individuals who keep refining this process day by day. Every single day, more than 15 billion cigarettes are produced worldwide. That is 173,000 every single second. But how does an ordinary tobacco leaf transform into a cigarette? What happens behind the closed doors of factories, where massive machines work non-stop to roll out thousands of packs every single hour? Today, we will reveal all the secrets, from enormous tobacco plantations to high-tech packaging lines. And you will be shocked at the hidden processes behind this industry. Stick around until the end so you do not miss the most fascinating details. The very first tobacco factory in Europe was established in Seville, Spain, in the year 1728. For over a century, this factory supplied Europe with cigars, generating substantial profits for the Spanish treasury. Today, Europe is home to major tobacco companies such as British American Tobacco, Philip Morris International, and Imperial Brands. For instance, in the year 2024, Imperial Brands reported an operating profit of £3.5 billion British pounds, which was 4.5% higher than the previous year. This growth was driven by a 26% increase in revenue from alternative products, such as electronic cigarettes and nicotine pouches. Growing tobacco requires a specific climate, as this plant thrives in warm weather and fertile soil. The primary regions for tobacco cultivation include North and South America, Africa, Southeast Asia, and Europe. The leading countries in tobacco production are Brazil, China, India, the United States of America, Zimbabwe, Turkey, and Italy. China is the world's top tobacco producer, cultivating more than 2 million metric tons of tobacco leaves annually, which accounts for over 40% of global production. The key tobacco growing regions in China are Yunnan, Guizhou, Hunan, and Sichuan provinces. India produces approximately 800,000 metric tons of tobacco per year, primarily in the states of Andhra Pradesh, Telangana, and Karnataka. Tobacco seeds are sown in the spring, and the leaves are harvested several months later. This process can take several weeks since each layer of leaves is collected separately. After harvesting, the leaves are transported to specialized facilities, where they undergo fermentation and drying. The most common drying methods include air curing, fire curing, or sun curing, depending on the type of tobacco. For instance, Virginia tobacco is fire cured, meaning the leaves are hung in curing barns where the temperature is carefully maintained using heated air. This process lasts about 7 to 10 days and gives the leaves a golden color and a mildly sweet aroma. Burley tobacco, on the other hand, is air-cured in shaded barns for an entire month, resulting in a more intense and dry flavor. After drying, the tobacco leaves go through fermentation, which helps reduce nicotine levels and remove excessive bitterness. This fermentation process can last several months. A large portion of the tobacco used for cigarette production in Europe is imported from Brazil, Zimbabwe, China, and the United States of America. Some countries, such as Italy, Greece, and Turkey, cultivate their own tobacco, which is also processed in local factories. Every batch of tobacco arriving at production facilities undergoes strict quality control, where factors like moisture content, color, and nicotine levels are analyzed. The process begins with the initial treatment of tobacco leaves. First, the leaves are sorted by quality and type, with damaged or unsuitable parts removed. On average, each cigarette contains approximately 1 gram of tobacco, meaning that large factories process hundreds of metric tons of raw materials daily. After sorting, the tobacco is processed in manufacturing plants, where machines take over most of the work. The leaves are first shredded into fine fibers. Machines meticulously control the size of these shredded pieces to ensure uniformity. Then, the tobacco undergoes steam treatment to increase its elasticity and improve storage conditions. Various flavorings and stabilizing agents are added to regulate moisture levels and enhance taste characteristics. Typically, cigarette blends include a mix of different tobacco varieties to achieve the desired flavor and strength. The next stage is cigarette formation. Production lines are equipped with specialized machines capable of rolling out more than 20,000 cigarettes per minute. These automated lines operate with incredible speed and precision. The process begins with shredded tobacco being evenly distributed onto a conveyor belt. Next to this belt, a continuous strip of cigarette paper is unrolled. The machine wraps the tobacco in the paper, forming an uninterrupted tube that resembles a long roll. This roll moves along the belt at high speed, and special cutting blades then slice it into individual cigarettes, each approximately 3 inches long. Filter production is a separate process that begins with a primary material, usually acetate fiber. This synthetic polymer is derived from cellulose, which comes from wood pulp. The fibers are treated with special chemicals to give them the required structure, after which they are pressed and formed into long strips. To bind the fibers, a plasticizer called triacetin is used, ensuring the filter maintains its shape. These long strips are rolled into cylindrical blanks, which can be several feet long. They are then cut into smaller sections that match the required filter length. On the production line, these filters are fed into a specialized mechanism that wraps them in a thin paper layer to reinforce their structure. A standard filter can weigh between 10 and 20 grams, depending on the type, and its volume can range from 1 to 3 milliliters. In large-scale manufacturing, several metric tons of acetate fiber may be processed daily, with the total volume of filters produced reaching hundreds of thousands of liters. Next, the filters are attached to the tobacco rod. This is done using wrapping paper that is bonded with food-grade adhesive to create a strong connection between the filter and the tobacco-filled portion. In the bonding area, the wrapping paper passes through a roller that evenly applies the adhesive to its surface. The filter and the tobacco rod are then precisely aligned and merged using a specialized mechanism. The wrapping paper is tightly wound around the connection point and firmly pressed to ensure a secure bond. This process happens in a fraction of a second, and each minute, the machine can attach hundreds of filters to tobacco rods. Throughout production, the total amount of adhesive used can reach several dozen kilograms per shift, while the length of tobacco rods passing through the equipment is measured in hundreds of yards. Once assembled, the cigarettes move along the conveyor to the inspection section, where the strength of the bonds, uniformity of the wrapping, and adherence to standard dimensions are checked. Special scanners and weight sensors examine each cigarette to detect any defects, such as hollow spots, uneven tobacco distribution, or damaged paper. Any defective items are automatically removed from the line. Another crucial step is the application of tracking codes on each cigarette or filter, ensuring full traceability throughout the production cycle. This is done with high-precision laser markers that do not damage the paper. Finished products are then cut to final lengths if needed before reaching the packaging section, where they are grouped into packs of 20 and wrapped in foil. Once cigarettes are paired with filters and pass quality control, they move to the packaging stage. First, the cigarettes are aligned on the conveyor, forming groups based on the intended pack size. A standard pack typically contains 20 cigarettes, although there are variations with 10 or 25 pieces. Once grouped, the cigarettes are wrapped in an inner lining made of foil paper or thin aluminum foil to maintain freshness and prevent drying. They are then automatically placed into cardboard boxes, which arrive via a separate conveyor. These boxes are made from thick cardboard that is pre-cut, folded, and glued using high-speed machinery. The packs then pass through a wrapping mechanism, which seals them in a thin, transparent film. This film includes a perforated strip for easy opening. At this stage, excise stamps and barcodes are printed. On average, a single packaging line can process about 15,000 packs per hour. Completed packs are arranged into blocks of multiple packs, usually 10 per block. These blocks are further wrapped in film or packed into cardboard boxes before being placed onto pallets for transportation. Large cartons can hold up to 500 packs each. The boxed products are stored in factory warehouses until they are shipped to distributor warehouses. From there, cigarettes are sent to stores, supermarkets, and specialized kiosks. Every day, dozens of trucks leave major tobacco factories, delivering millions of cigarettes to distributors and retail locations. The entire journey, from manufacturing to store shelves, can take anywhere from a few days to several weeks, depending on logistics and market demand. At large tobacco factories, machines operate continuously across multiple shifts. In a single workday, one of these machines can produce several million cigarettes. Modern cigarette manufacturing is characterized by a high level of automation, minimal human involvement in production, and rigorous quality control at every stage. Factories are equipped with air quality management systems to maintain stable humidity and temperature, which are crucial for preserving tobacco properties. A typical tobacco factory can produce up to 200 million cigarettes per day, amounting to thousands of metric tons of finished products each month. Every year, we produce approximately 101 million short tons of textile waste, and more than half of that trash simply rots in landfills. But what if we could turn it into something useful? Imagine this: your favorite t-shirt, a stylish blazer, or even designer sneakers, all made from plastic bottles. Yes, fashion is already changing, and brands are turning waste into trendy clothing. How exactly does plastic become fabric? Why are large companies already earning millions from this? And does such clothing truly save the environment? Let us figure it out. Every year around the world, approximately 101 million short tons of textile waste are produced, of which only 15% is recycled, while 57% ends up in landfills. We need to do something about that, right? It might sound like science fiction, but in fact, plastic can be easily recycled into fabric. Let us start with the fact that most of the textiles we wear every day consist of synthetic fibers, such as polyester. Here is something interesting. Polyester is nothing more than plastic. Yes, you understood that correctly. Plastic bottles or other plastic waste can be turned into fibers that are then used to make fabrics. The process looks like this. Old plastic bottles, plastic containers, or even damaged plastic items are collected, washed, cut into small pieces, and then these pieces are melted down into new plastic fibers. These fibers are then woven into fabric that, in terms of its characteristics, is almost no different from traditional materials like cotton or wool. Now imagine this. It is not just a technological marvel, but also a chance to reduce the amount of plastic that ends up in nature. This usually happens in the following way. Plastic is sorted by type of plastic, most frequently polyethylene terephthalate, and by color. Clean and transparent plastic is more valuable because it is easier to obtain high-quality raw material from it. After that, the waste is washed in special baths to remove any remaining beverages, glue, and labels. Then, special industrial shredders equipped with sharp blades cut the plastic into uniform fragments. Sometimes water cooling is used for this purpose, in order to avoid overheating the material. The smaller the plastic is shredded, the easier it is to melt and clean it from impurities. Next, the shredded plastic is heated to about 932 degrees Fahrenheit until it becomes a viscous liquid mass. Then, this melted mass goes through special filters to remove any remaining contaminants. After that, it is extruded through fine nozzles, creating thread-like fibers. These fibers are cooled by a stream of air or water, after which they are twisted into yarn that becomes the basis for textile materials. It is impossible not to notice that fashion is now moving towards sustainability. All those popular brands we know and love, such as Adidas, Patagonia, and Stella McCartney, are increasingly using recycled plastic in their collections. However, let us pause here. What makes this plastic so popular? Environmental friendliness. As we know, plastic is one of the biggest enemies of the environment. Every year, millions of short tons of plastic end up in landfills or in oceans. But through recycling, we can reduce that impact by turning plastic waste into useful materials. And this is not just one of the eco-initiatives of brands, it is a real shift in the industry. Interestingly, some designers and brands already use textiles made from recycled plastic, not only for environmental benefits, but also for the unique look. In particular, materials made of plastic fibers can have very intriguing texture and sheen, which gives clothing a bit of an innovative and futuristic appearance. Imagine a t-shirt that is not only made from plastic, but also has a striking texture that reminds us of the future. Research shows that reusing textiles can save up to 8 short tons of carbon dioxide and approximately 164 gigajoules of energy for every short ton of textile waste. Converting that to American measures, 164 gigajoules is about 155 million British thermal units. Recycling textiles saves 5 6/10 short tons of carbon and about 116 gigajoules of energy per short ton, which is around 110 million British thermal units. That is a considerable difference on a global scale. Technology. Fabrics made from recycled plastic can be just as comfortable and stylish as regular fabrics. They even have certain advantages. They are water repellent, resistant to fading, and they hold up well to wear and tear. Moreover, if these fabrics are processed correctly, they can be made soft and pleasant to the touch. And here, we should remember another point: microplastic that can enter water through recycled fabrics. When we wash clothes, especially items made from synthetic materials, microscopic plastic particles can get into the water. However, some brands are already working on solutions to minimize this impact. For example, they use special technologies to reduce the release of microplastic during washing, or they create materials that are less prone to this. Innovation. However, it is worth noting that this is not just a trend. It is an innovation. Instead of continuing to produce more plastic, brands are finding ways to use what already exists. This opens up new possibilities for the fashion industry. For instance, one of the most fascinating technologies is recycling ocean plastic. The same plastic that is flooding our oceans can also be turned into clothing. For example, the company Parley for the Oceans creates materials from plastic collected from the oceans. This not only helps decrease the amount of plastic in the water, but also becomes the foundation for eco-friendly collections by brands such as Adidas. That is a whole different story, right? If you think that recycled plastic is something only for sportswear or accessories, you are mistaken. Imagine a stylish coat or an elegant dress made from material that was once a plastic bottle. These recycled plastic fabrics make their way onto the runways of major fashion shows and become part of refined collections. One of the most interesting examples is the Stella McCartney collection, which recently introduced a clothing line made from fabrics produced from recycled plastic bottles. And of course, you will not find any trace that these fabrics were ever anything else. They look and feel completely sophisticated. This is not merely about disposal. It is about creating genuine art out of what we used to throw away. Speaking of scale, some countries, such as the Netherlands or Sweden, have become true leaders in plastic recycling. There are even specialized factories there that transform plastic waste into textile, which then becomes part of both sports and everyday clothing. It is an entirely new approach to waste processing that not only helps preserve resources, but also creates new jobs. It turns out that the process of recycling plastic into textile not only saves the planet, but also has significant economic potential. Many small startups around the world have begun to build business models based on the collection, recycling, and resale of plastic waste in the form of clothing. Such businesses often collaborate with local communities, involving them in collecting and recycling waste, which creates new jobs and stimulates the economy at a local level. Technologies of three-dimensional printing also use recycled plastic to create fabrics. Some companies have already started making textile materials by utilizing plastic waste through three-dimensional printing. This allows the creation of entirely new textures and shapes, as well as optimizing the clothing manufacturing process. Imagine clothing that is literally printed using plastic. In recent years, the so-called smart fabrics have also been gaining popularity in the textile industry. Materials that can change their properties depending on the surrounding conditions. Recycled plastic has a role here as well. Some brands are experimenting with integrating nanotechnologies into fabrics made from recycled plastic, enabling the creation of textiles that respond to temperature or moisture, making clothing more functional and comfortable. It sounds like something from a fantasy, but there are already materials made from recycled plastic that can self-clean. They have special coatings that allow the fabric to repel dirt and water. This technology can change the rules of the game in terms of durability and convenience, because clothing made of such fabrics would require much less washing. Another exciting direction involves fabrics that alter their appearance depending on how a person interacts with them. For example, fabrics that respond to body heat or change color during movement. All of these innovations can be created using recycled plastic, opening up new opportunities in fashion. One more interesting aspect is the recycling of plastic into artificial leather. Some innovative brands have already started making eco-friendly artificial leather out of recycled plastic waste. Such leather can be used to manufacture bags, footwear, and even outerwear. This offers a material that resembles genuine leather, but without the use of animal products and with a smaller environmental impact. Here is the thing. Today's youth is a generation that is becoming increasingly aware of environmental issues. You are no longer just buying clothing. You are buying clothing that tells a story. You are buying not just fabric, but a certain idea. A future that can be more sustainable and clean. And when you wear clothing made from recycled plastic, you are not merely shopping. You are joining the change. You are becoming a part of this large movement. Of course, there are questions about the cost, quality, and availability of such materials. But do you know what? It is only a matter of time. With the advancement of technology and the growth in demand for eco-friendly products, these fabrics will become even more affordable. And that is great, because each of us can contribute to improving the situation. Perhaps in a few years, we will only wear clothing made from recycled material. And, to be honest, that does not seem so fantastic. It might become the norm, rather than the exception. And who knows, maybe in the future, even your favorite brand will use plastic waste to create new trendy items. Yes, it sounds like science, but science and fashion can accomplish many wonders together. So the next time you are choosing what to wear, think about this. Maybe it is another step toward a better world. And if plastic waste can become part of your style, then why not? Every year, thousands of peacocks are bred in China, generating billions of dollars in revenue. These birds are not just a lavish addition to estates, they are a true gold mine. Their feathers sell for dozens of dollars per piece, and their meat is served in luxury restaurants for hundreds. But did you know that peacocks are also bred for cosmetics and traditional medicine? How did China turn these exotic birds into a global business? Let's find out. At first glance, a peacock seems like nothing more than a decorative bird. However, China's peacock breeding industry has long moved beyond simple admiration for their beauty. Farmers supply peacocks to parks, reserves, hotels, high-end restaurants, and even private estates. The price of a single bird can range from $100 to $1,000, depending on the breed and coloration. Albino peacocks and rare varieties with unusual color patterns are especially sought after. Peacock feathers are widely used in high fashion, theater productions, and jewelry making. Long, iridescent feathers sell for dozens of dollars each, while exclusive sets can fetch hundreds. Chinese farmers carefully collect molted feathers, creating an entire market around them. While eating peacock meat is considered unacceptable in many cultures, in China, it is served as a gourmet delicacy in high-end restaurants. It is said to resemble pheasant, but with a more tender taste. The price of a portion of peacock meat can range from $50 to $100. Peacock fat and extracts are used in traditional Chinese medicine and cosmetics. These are believed to have rejuvenating and healing properties, making peacocks yet another lucrative source of income for farmers. At large farms, tourists can not only observe the birds, but also feed them, take stunning photos, or even purchase a feather as a souvenir. This business attracts additional investments and increases the value of peacock farming. It seems these birds generate profit with every aspect of their existence. Peacocks have been bred for thousands of years, fascinating people since the times of ancient Egypt, Greece, and China. It is believed that the first domesticated peacocks appeared in India, where they were revered as sacred birds. They were later transported to Persia and eventually to Europe. The ancient Romans not only admired peacocks, but also served them as a banquet delicacy. However, the real boom in peacock farming began in China during the 20th century. Farmers quickly realized that these birds were not just decorative, but also highly profitable. Before the coronavirus outbreak in the year 2020, China had approximately 20,000 farms breeding various wild animals, including peacocks. This industry generated around 74 billion United States dollars and provided jobs for 14 million people. After the outbreak, the Chinese government shut down these farms due to concerns about virus transmission from wild animals to humans. The size of a peacock farm can vary significantly depending on the scale of production and breeding purposes. Small private farms may occupy just a few thousand square feet, while large commercial facilities span multiple acres. The ideal farm size depends on ensuring the birds have enough space for comfortable living and breeding, while efficiently organizing farm infrastructure. Peacocks require ample space to move freely and display their magnificent tails. The recommended area per bird is approximately 100 to 160 square feet. This means that a farm with 100 peacocks would need at least 11,000 to 16,000 square feet of open space. Additionally, space must be allocated for shelters, feeders, incubators, and other farm structures. Choosing a location also depends on climate conditions, access to feed and water, and proximity to sales markets. In regions with mild climates, peacocks can be kept outdoors for most of the year, reducing shelter construction costs. However, in areas with cold winters, farmers must provide heated enclosures, increasing the farm's overall footprint. Everything starts with eggs. Wild peacocks lay up to 20 eggs per season, but on farms, with proper care and a balanced diet, a single female can produce up to 40 eggs. The eggs are collected and placed in incubators, special machines maintaining a temperature of 99.5 degrees Fahrenheit and humidity around 60%. Under these conditions, embryos develop, and in 27 to 30 days, the first chicks hatch. Newborn peacock chicks are highly sensitive to temperature, so they are kept in heated enclosures at temperatures ranging from 85 to 95 degrees Fahrenheit during their first weeks. They are fed finely chopped boiled eggs, millet, and special protein, and vitamin-rich feeds. By 1.5 months, they begin to grow faster and are transferred to larger enclosures. It is crucial to provide at least 3 square feet per bird. Otherwise, they may start competing for space and food. Peacocks grow slowly. It takes 2 to 3 years for them to reach their full size and develop their spectacular plumage. During this time, farmers carefully monitor their diet, living conditions, and health. The birds are fed grain mixtures, greens, insects, and protein supplements. An adult peacock consumes slightly more than 1 pound of feed per day. Although peacocks are quite resilient, they can suffer from viral and bacterial infections. Farmers vaccinate them and conduct regular feather inspections. Checking feather quality is a crucial aspect of peacock care, especially on farms where they are bred for sale or decorative purposes. Farmers or veterinarians examine feathers for damage, molting, parasites, and overall health. They check for broken, dull, or missing feathers. The brightness and uniformity of the coloration indicate the bird's well-being. Feathers and skin are also inspected for mites, lice, or fungal infections. The tail feathers of males receive special attention, as they are the primary decorative feature. Farmers carefully spread them out to assess length and integrity, ensuring molting occurs naturally. Peacocks molt annually, and this process lasts for 2 to 3 months. If necessary, birds are bathed in special parasite treatments, or their feathers are conditioned with nourishing agents. When peacocks reach the desired age, they are categorized based on purpose. The most beautiful and healthy males and females are sold for decorative purposes. Some birds are kept on farms to continue breeding. Every year, peacocks shed their magnificent feathers, which farmers collect for sale. These feathers are used in fashion, decor, and art. Of course, some birds are also processed for meat. Peacock meat is dark and tender, somewhat similar to pheasant, but with a richer aroma. It is often prepared with citrus fruits, wine, or spices to enhance its refined flavor. Despite being exotic, peacock meat remains a niche product, but for farmers, it is yet another revenue stream. The purchase of peacock carcasses is a niche yet stable market. Restaurants and hotels place regular orders, though in limited quantities. Private customers usually buy peacock meat for special occasions. Who buys peacocks for consumption? High-end restaurants, especially in China, India, and the Middle Eastern countries. Chefs order peacock meat for exclusive dishes served in VIP rooms or at special events. Wellness centers. Some Asian practices believe peacock meat has medicinal properties. It may be recommended for boosting immunity or as an energy-rich food. Luxury hotels. Large resort complexes catering to affluent tourists may include peacock dishes on their menus. As for feathers, peacocks shed their plumage annually, allowing farmers to collect up to 200 long feathers per bird without harming them. This is a distinct business sector, as peacock feathers are used in high fashion for clothing and accessories, stage costumes, jewelry making, interior decoration, and cultural rituals. Farms export feathers worldwide, generating a significant portion of their revenue. Peacocks are sold through zoological farms, online stores, and specialized auctions. Chinese farmers have mastered promoting their products through social media and even use live streams to showcase their birds to buyers. Peacock exports from China are growing rapidly. The highest demand comes from the Arabian countries, the United States, India, and Europe. Peacock feathers are transported worldwide using various methods depending on volume and destination. Feathers are either hand-plucked or removed with special tools, then carefully packaged to prevent damage. They are primarily collected during natural molting when the feathers fall off on their own. Feathers are meticulously packed in special boxes or bags to prevent bending or breaking during transport. Soft materials such as paper or fabric are often used for extra protection. Thanks to modern logistics systems, peacock feathers can be shipped by sea, air, or rail. Large shipments are usually transported by sea freight, while air freight is used for faster deliveries. Since peacock feathers may be subject to export and import regulations, proper documentation and certification are essential for customs clearance. Specialized logistics companies with experience handling delicate cargo typically manage large-scale or international shipments. Every year, more than 22,000 short tons of amethyst are mined all over the world. But how do these unique purple crystals end up on display in jewelry stores? Picture enormous geodes, each roughly the size of a person, packed with dazzling crystals that miners extract from remote regions in Brazil, Uruguay, and Africa. Some of these geodes are so rare that they are transported by helicopters. However, did you know that only about 10% of all discovered amethysts are of jewelry quality? let us dive into a world where nature creates masterpieces and humankind unveils them for everyone to see. Brazil is one of the largest suppliers of amethyst on the planet. The main deposits are located in the states of Rio Grande do Sul and Minas Gerais. In Brazil, amethyst geodes are often found, which are hollow stone formations lined with crystals on the inside. Some geodes can reach over 9 feet in height. Uruguay is famous for its amethyst that has a rich, dark purple hue. This stone is usually of higher quality than the Brazilian variety. Geodes from Uruguay are considered extremely valuable because of their depth of color. The African continent, particularly Zambia, is also an important source of amethyst. Zambian amethysts feature a unique purple color with a bluish tint. They are mined in considerable volume, but the deposits are located in hard-to-reach regions, making transportation more complicated. Amethyst deposits in the United States are not as large-scale as in Brazil or Uruguay, but they have their own special history and appeal. The amethyst found in the United States is prized for its vibrant coloring, historical significance, and local popularity. So, let us take a closer look at the main locations and their distinctive features. Four Peaks is the most renowned and likely the largest amethyst deposit in the United States, situated in Arizona, at an elevation of about 7,545 feet above sea level. The amethyst from Four Peaks is noted for its deep purple color with a subtle reddish glow. Many believe these stones can compete in quality with even the most valuable specimens from Uruguay. The deposit is located in an extremely challenging spot. There are no roads, so miners and equipment are transported by helicopters or on mules. This is one reason why stones from this deposit are so expensive. The mining process is physically demanding and costly. Most of these mines are small, and much of the work is done manually to avoid damaging the crystals. A modest region in the northern part of Georgia is home to lighter, pastel-toned amethysts. Although the deposits are not as extensive as those in Arizona, the stones exhibit a unique clarity and a pleasant purple hue suitable for more affordable jewelry. Local specimens are often mined in small private shafts or even during special tours that allow tourists to try their hand at being treasure hunters. This aspect adds a certain charm to Georgia amethysts, as they become both a souvenir and a cherished memory. The Creede area in Colorado was once more famous for its silver mines. However, there are certain spots where amethyst deposits can be found as well. These stones tend to be lighter in color and less intense in saturation, yet they possess interesting inclusions that give them a unique character. Amethysts from Creede are frequently used to make cabochons, which are smooth, unfacetted stones suited for decorative ornaments. Amethyst usually forms in volcanic rocks, where high temperature and pressure conditions cause quartz to absorb iron impurities, then cool over thousands of years. The outcome is a deep purple crystal that makes you pause and exclaim, "Wow!" For example, in Brazil, miners uncover enormous geodes lined with crystals. Sometimes these geodes are so large that they appear at exhibitions, where people take photos beside them, as if they were standing next to a work of art. Now imagine this scene: a team of miners wearing hard hats, equipped with headlamps and pickaxes, searching for just the right pockets of stone where these priceless cocoons lie hidden. Believe me, it is no simple task. Today, miners do not rely solely on luck in their pursuit of amethyst. Their primary allies these days are science and technology. The process starts with detailed geological mapping. Geologists investigate regions that are well known for containing abundant quartz, the primary mineral from which amethyst arises. For instance, in Brazil, the world's largest amethyst producer, researchers target geological formations ranging in age from 50 million years to 200 million years. One of the most advanced tools is high-resolution satellite imagery. Through spectral analysis of the colors on the Earth's surface, specialists can pinpoint hues that hint at the presence of specific minerals, including quartz. Moreover, seismic sensors contribute to the creation of three-dimensional models of the underground layers of soil. These devices detect even minute reflected waves that tell the story of the materials hidden below the surface. Yet, as strange as it may sound, Intuition and hands-on experience still play a huge role. For instance, miners in Rio Grande do Sul in Brazil claim that deep reddish-brown soil nearly always indicates proximity to amethyst. Such observations help them concentrate their efforts exactly where the odds of discovering stones are the greatest. Statistics show that only about 5 to 10% of all areas that look promising based on maps or satellite data actually harbor commercially valuable deposits. In Brazil, which accounts for over 40% of the global amethyst market, dozens of new zones are surveyed every year, but only a handful proceed to the extraction phase. The average depth of an amethyst mining site seldom exceeds a few dozen feet, but these locations demand enormous amounts of preliminary work. According to the United States Bureau of Mines, launching a single mine may require as long as 3 years and cost anywhere from $50,000 to $100,000 before unearthing even a small pocket of amethyst. This illustrates how labor-intensive and expensive the quest can be, even for gems as popular as amethyst. Ultimately, technology, expertise, and a hint of intuition collaborate to uncover those mysterious purple treasures that we admire in jewelry. Although the probability of finding the ideal crystal is slim and the miner's work is strenuous, the reward is unquestionably worthwhile. The amethyst extracted from a mine looks nothing like what you see in a display case. It is often covered in rocky residue, irregular in shape, sometimes almost opaque. Once it is mined, the stone goes to a factory, where a kind of magical transformation unfolds. First, the crystals are cleaned, occasionally by hand, and occasionally in massive tumblers that literally scrub away the dirt. Then each stone is sorted by quality. Here is the interesting part. Only about 10% of all the amethysts unearthed are of jewelry-grade quality. The rest are used for more budget-friendly accessories or even ornamental items. The next step is cutting. This is a true art that merges careful science with the delicate touch of a skilled artisan. Picture a person peering through a loupe, meticulously turning the stone to find the ideal angle. The most fascinating aspect? One slip of the hand can cause the crystal to crack. Let us suppose the stone is finished. The next issue is transportation. This task is not as straightforward as one might initially assume. Certain amethysts travel in specialized boxes, padded with foam inserts to protect them from the faintest jostles. In the case of geodes, they are often packed in wooden crates lined with soft materials. Uruguay has a distinctive export program for its amethysts. Stones are sold directly at auctions, drawing buyers from all over the globe. In Brazil, on the other hand, most of the output goes straight to large enterprises that handle both cutting and further distribution. The price of amethyst is determined by factors like color, clarity, and size. The most expensive pieces boast a vivid purple tone with a slight reddish shimmer, often called deep royal. Such stones are frequently utilized in luxurious jewelry, which can appear at international auctions. Here is something surprising. Even though technology has improved remarkably, a great deal in this field still hinges on human effort and observation. It is a tradition passed down through many generations. Even the extraction itself relies more on manual labor than on large machinery. Initially, after identifying a promising zone, preliminary work begins. If the amethyst is near the surface, excavators remove the topsoil, creating large open pits. In places like Minas Gerais and Bahia in Brazil, these open pits can span several dozen feet across. However, if the amethyst is buried deep, the operation goes underground. Mines that yield this crystal can extend about 320 feet into the earth, forming a vast maze of tunnels branching out in all directions. Breaking through the tough layers of rock is the first step to reaching amethyst. This may involve using explosives or drill rigs, but it is not as dramatic as one might imagine. It must be done very carefully to avoid shattering the precious crystals. The people responsible for this work are genuine experts. They even live by an informal motto: it is better to go around than to destroy. A carelessly managed blast can reduce a stone to fragments. Once the deposit is exposed, miners proceed by hand or with small tools to gently dislodge the crystals. Envision the scene. Darkness, illuminated only by the glow of headlamps, and silence broken by the occasional strike of a pickaxe or the hum of a handheld saw. Everything relies on the miner's dexterity. Even the most subtle motion can determine whether a crystal remains intact or breaks. Some refer to this phase as jewelry-level work. The amethysts that are found are typically surrounded by quartz, rock, and clay, so they are cleaned right there in the mine. This is painstaking work, removing layer after layer, and taking care not to harm the delicate crystal structure. It is reminiscent of restoring an antique vase. The most valuable crystals are separated by hand, with every movement carefully planned. Interestingly, the ambience in these mines can be quite a spectacle. For example, in the famous Las Vegas mine in Uruguay, amethysts shimmer in the darkness under the beam of a lamp, creating the sense of stepping into a magical subterranean realm, radiating shades of purple and blue. In some locations, such as the Amethyst Park in Brazil, the mines are open to visitors, and people can witness firsthand how skilled workers gently extract the crystals from the walls. Those workers are the real heroes. They toil in challenging conditions. Have you ever wondered how the beer you drink is made? Imagine this: 1 million tons of grain every year, thousands of bottles filled every minute, and automated machines working with millimeter precision. We are diving into the world of brewing at the Anheuser-Busch factory, the largest beer producer in the world. We will discover how ordinary barley transforms into a hoppy beverage, and why every drop of Budweiser undergoes meticulous quality control. This is not just production. It is a spectacle of scale, flavor, and innovation that you absolutely will not want to miss. Did you know that the average American drinks about 2,500 ounces of beer annually? And while the Czech Republic and Germany lead in beer consumption, Anheuser-Busch supplies a significant portion of the global demand. It all begins with humble barley. At the factory, I witnessed how tons of grain are delivered and processed before being turned into malt, one of beer's main ingredients. Everything here is automated. Specialized machines grind the grain and soak it in water to wake up the enzymes. It literally looks like a dance of machinery, with each piece knowing its role precisely. In enormous steel tanks as tall as a 3-story building, giant machines load tons of golden barley. You can hear the soft, calming sound of the grain cascading downward, reminiscent of gentle rain. What happens next is pure technological magic. Special machines delicately grind the grain, exposing its core, starch. It looks as though the grain passes through a massive waterfall, transforming into a light, fluffy powder. This powder then ends up in enormous vats filled with warm water. Here is an interesting fact. The machines do not simply soak the grain in water. They maintain an ideal temperature and humidity level, like a steam bath designed to activate the enzymes. You can see the vats come alive with hot steam passing through them. Water mixes with the ground grain, forming a thick, creamy mixture that begins to release the aroma of freshly baked bread. This moment feels incredibly vivid. It is as if the grain awakens and starts working together with this mechanical orchestra. The malt vat begins to rotate. Yes, it does not just sit still. It practically dances, with special paddles mixing the blend so the enzymes activate evenly. Steam rises, forming a light mist that fills the room with a sweet aroma. Sometimes this steam is lit with special lamps, adding a touch of spectacle, as if you are witnessing a scene from a sci-fi movie. And this is only the beginning. The porridge then passes through other tanks equipped with precise filters that separate the liquid, the malt extract, from the leftover grain. Now imagine this happening on a scale where a single processing cycle can fill thousands of bottles of beer. This is not just production, it is a full-scale performance. The machines operate with the precision of fine jewelry, and as you stand nearby, you feel like a witness to something monumental. The entire process is filled with rhythm, aromas, and sights that will make you forever respect beer. Though, to be honest, I already respect beer because it sponsors my enjoyable Friday nights. Anheuser-Busch sources barley from various farms, and the quality is scrutinized down to the smallest detail. Different beers require different malts. Lager? A light malt base is needed. Stout? Add darker, roasted malt. You get the idea. They use around 1 million tons of grain annually for beer production. Now for the most exciting part. These giant steel fermentation tanks are so enormous that it feels like you could fit an entire football team inside one. This is where the magic begins. Maltwort, a sweet liquid extracted from the grain, is mixed with hops and yeast. Honestly, the smell in the fermentation hall is something else. It is a warm, rich aroma reminiscent of bread and fruits. The yeast here works like crazy, turning sugar into alcohol and carbon dioxide. Fermentation lasts anywhere from several days to a few weeks, depending on the type of beer. The factory employs about 4,000 people. It is like a small town. But what surprised me the most is the level of automation. People here mostly monitor the process from screens while the machines handle the bulk of the work. Even the smallest details, like the temperature and pressure inside the tanks, are controlled by computers. Honestly, the factory feels more like a scientific laboratory than a traditional brewery. And it did not start out this technologically advanced. Anheuser-Busch has an incredibly fascinating history. It all began in the year 1852, when a small brewery opened in St. Louis, simply called Bavarian Brewery. In the 1860s, it was purchased by Eberhard Anheuser, a German immigrant, and his son-in-law, Adolphus Busch, joined the business a few years later. That is when the real boom began. Adolphus Busch was not just an entrepreneur, but an innovator. Imagine this. In the year 1876, they created Budweiser, the first American lager beer. To make it accessible anywhere in the United States, Busch introduced revolutionary transportation methods, such as refrigerated rail cars. This was a game changer for the beer industry. Today, Anheuser-Busch is part of the AB InBev Corporation, the largest beer producer in the world. Their brands, Budweiser, Michelob, Stella Artois, Corona, are recognized on every continent. According to AB InBev, Budweiser alone is sold in over 85 countries, producing over 2,064 million gallons of beer annually. On average, each production line fills 1,500 bottles or cans per minute. The bottling line is a true showcase of technical perfection. Hundreds of cans and bottles flow in rapid streams, perfectly aligned, gleaming under bright lights. The entire process is fully automated, and watching it is like observing a finely tuned clock mechanism, but on an enormous scale. First, empty bottles or cans enter the conveyor. They are thoroughly washed to remove even the tiniest specks of dust, because cleanliness here is paramount. Machines spin each container under spiral nozzles that shower them with jets of water. Next comes the filling stage. Cans line up under high-precision dispensers that pour the exact amount of beer into each one in mere fractions of a second. Interestingly, this happens in near-vacuum conditions. Why? To prevent foam formation and avoid any contact between the beer and oxygen, as this could affect its flavor. The next step is sealing. Caps for bottles or lids for cans are fed onto the conveyor through a separate line, and special automatic clamps secure them with such speed that it is almost impossible to see the movement with the naked eye. Then comes the packaging. This is where the real conveyor magic happens. Bottles, cans, kegs, everything moves at lightning speed. More than 1,500 bottles are filled and sealed every minute. Watch this rhythm. Every can undergoes a seal test before moving on to packaging. Here is another interesting detail. Bottle coloring and label printing are also automated. Conveyors move, machines blink, and staff only occasionally intervene to ensure everything runs smoothly. Overall, lasers, sensors, and cameras at every stage ensure quality control. If even a single can or bottle fails to meet standards, the machine instantly removes it from the line. This guarantees that only the best product reaches consumers. Despite the scale of production, the taste of the beer remains consistent. That is their top priority. Every batch undergoes tasting before hitting the shelves. And trust me, this is not just a formality. The tasters here work at the level of true sommeliers. And this is just one factory in the Anheuser-Busch network. In total, the company operates 12 breweries in the United States, along with over 20 distribution centers. Another thing that impressed me, Anheuser-Busch actively works to reduce its environmental impact. For instance, the water used in brewing is purified and reused, and all waste, such as grain husks, is sent to farms as livestock feed. You can now tell your spouse, Honey, I am not just drinking beer, I am supporting cattle feed in the United States. If you survive saying that, let me know how it goes. Although their largest factories are in the United States, the company has facilities on every continent except Antarctica. By the way, the factory in St. Louis is also a tourist attraction. Every year, they host tours for tens of thousands of visitors. Guests are taken to historic production halls, shown giant tanks, and even get to see their famous Clydesdale horses. And if you are wondering whether you can taste the beer, of course. At the end of each tour, guests are invited to a tasting room to sample the freshest beer. Anheuser-Busch is not just a company, it is a living history of innovation, scale, and tradition. They started as a small brewery in St. Louis and have grown into a giant that is reshaping the beer industry. Next time you open a bottle of Budweiser or Michelob, remember these numbers, this scale, and the people behind every drop of beer. Imagine this, a house printed in just 24 hours. Sounds like science fiction, right? But it's real. Back in 2018, the United States saw its very first 3D printed house. Today, there are hundreds of these homes, and the numbers keep growing. This technology doesn't just build houses. It's redefining architecture with designs that are both stunning and efficient. And the best part? A home like this could cost as little as $10,000. Ready to see how a giant printer turns concrete into cozy living spaces? Let's dive in. The first 3D printed house in the US appeared in 2018. Now, there are hundreds of these homes, and the count is steadily climbing. Let's start with the basics. 3D printing is a technology that creates objects layer by layer using specific materials. When it comes to houses, this means a massive 3D printer extrudes concrete or other construction materials based on a pre-designed blueprint. Think of squeezing frosting from a piping bag, except instead of frosting, it's concrete, and instead of a cake, it's a fully functional house. These 3D printers are no small feat. They're massive. Imagine a structure the size of a small crane or a garage hangar. For example, Icon, a Texas-based company, uses a system called Vulcan. This printer stands about 11 feet tall and spans over 32 feet in width. Its modular design allows it to expand and adapt to the size of the house being built. The printer operates on rails or special platforms, moving around the construction site. That's why it can print anything from a tiny cottage to a spacious home. Essentially, it's like a large truck, a smart, precise machine that gets the job done with remarkable accuracy. Let me tell you about my visit to one of these construction sites. Icon, based in Texas, invited me to see their house printing process up close. And let me tell you, watching this gigantic printer in action makes you feel like the future is already here. It all begins with architects designing the house on a computer. It's like those 3D renderings you've seen in movies or on designer websites. Depending on the complexity of the design, creating a 3D model can take anywhere from a few hours to several weeks. A simple, single-story house without elaborate details might only take a day or two. But a complex project with unique shapes, energy-efficient features, or intricate interiors? That's a whole different ballgame. Here, architects work closely with engineers to ensure everything checks out. Will the walls hold up under pressure? Are the windows and doors positioned correctly? Are the local climate conditions accounted for? The coolest part? Modern software like AutoCAD, Revit, or SketchUp makes this process faster and allows for detailed visualization of every inch of the house. At the construction site, a massive 3D printer is set up. This printer, essentially a giant robot, moves on rails or with manipulators. It starts printing the house layer by layer. The main material? A special quick-drying concrete that becomes incredibly strong. Once the walls are done, the roof, windows, doors, and other elements are added. At this stage, traditional construction methods are used to finish the house. While the printer can handle the main structure, components like the roof, windows, and doors are typically crafted from traditional materials like wood or metal. For example, the roof might be made of metal or wood, depending on the project. Windows and doors are also custom ordered and installed using conventional construction techniques. This blend of innovative technology and proven materials ensures homes that are not only efficient, but also comfortable to live in. The entire process takes anywhere from a few days to a few weeks, a stark contrast to traditional construction, which can drag on for months. 3D printed homes have a ton of advantages, making them an increasingly popular choice. For starters, they can be built in just a matter of days. These houses are also significantly cheaper than traditional ones. According to Icon, a small home can cost as little as $10,000. And the designs? They're nothing short of art. This technology also minimizes waste and uses eco-friendly materials. Traditional construction often leads to a lot of leftover materials like concrete, wood, and metal, especially when cutting pieces for doors, windows, or walls. But with a 3D printer, materials are used only where needed. The printer lays down each layer precisely according to the design, leaving no excess material behind. It's not just about efficiency, it's about sustainability too. Many companies involved in 3D construction use materials that have a lower environmental impact. For instance, the concrete might include recycled components or be made with eco-friendlier ingredients, reducing pollution during production. Moreover, precise material calculations mean fewer resources are consumed, eliminating the need for extra stock or creating waste that ends up in landfills. This approach not only saves money, but also significantly reduces the environmental footprint of construction. The technology also opens doors to new types of eco-friendly materials, such as biodegradable concrete that incorporates recycled waste or organic substances. These materials reduce CO2 emissions and the need for extracting new resources. So, 3D printing isn't just speeding up construction, it's making it more sustainable and environmentally friendly. It's not just a trend, it's a real shift in the construction industry, one that could greatly improve our ecological outlook for years to come. Of course, it's not all perfect. The technology is still new and comes with its challenges. Currently, most 3D printed homes are made of concrete. But for more complex designs, new materials will need to be developed. These massive printers are also hard to transport and require specific conditions to operate. Plus, many countries don't yet have clear regulations for constructing such homes. Icon can print a house in just 24 hours. One driving factor behind this technology is its potential to address affordable housing shortages. 3D printing dramatically cuts costs on materials and labor. For example, Icon is working on a project to build homes for low-income families at just $4,000 each. The technology also unlocks incredible possibilities for architects. A 3D printer can create intricate, unconventional shapes that are almost impossible with traditional methods. Architects now have the freedom to design without limits, knowing the printer can handle any form or detail. The future of 3D printed homes looks incredibly bright. These technologies are already being used not just for housing, but also for offices, schools, and even hospitals. Icon is building the first fully 3D printed neighborhoods, including a project in the US in 2021 that delivered 5 homes to financially struggling families. And here's what blew my mind. Icon is working with NASA to print homes on Mars. Imagine that. One day, people might live in 3D printed houses not just on Earth, but on other planets too. Icon was founded in 2017 in Austin, Texas, by a group of engineers and entrepreneurs. Their goal was ambitious, yet simple: to create technology that makes housing fast, affordable, and sustainable, especially for those with limited access to traditional homes. The idea came when the founders realized the construction industry was bogged down by outdated methods and high costs for materials and labor. They envisioned 3D printing as a way to simplify the process, lower costs, and provide homes for those in need. Initially, Icon started as a small startup in the construction sector. It quickly gained traction and attracted major investments. Soon, Icon partnered with the Bjarke Ingels Group to create a groundbreaking 3D printed house, marking a significant milestone in the industry. This was the first house printed using technology that reduced material and labor costs. From there, they scaled up to build larger homes for various social programs. In the following years, Icon secured significant funding from venture capital firms, allowing them to improve their technology and expand production. For instance, in 2020, the company raised $35 million, enabling them to grow their operations and launch new projects. Every year, Americans consume around 46 million turkeys during Thanksgiving. Ever wondered how many steps a turkey goes through before it lands on your dinner table? And no, it's not just about becoming the star of your holiday feast. From small family farms to massive industrial complexes, the story of turkeys is fascinating, a bit surprising, and definitely worth your attention. Ready to break it all down? Let's dive in. It all starts with eggs. On specialized farms, breeding turkeys lay eggs, which are carefully collected by workers or automated systems. These eggs are then sent to hatcheries. Think of them as nurseries for future birds. In the United States, turkey farms range in size, from small family-run operations to large commercial enterprises. According to the United States Department of Agriculture, 99% of all farms in the country are family-owned. However, medium and large-scale family farms account for 68% of production, highlighting their critical role in American agriculture. The U.S. is one of the world's leading producers of turkey meat. Key turkey-producing states include Minnesota, Indiana, Missouri, and Arkansas. Overall, turkey farms play a vital role in the agricultural sector, supplying a significant portion of domestic consumption and exports. On larger turkey farms, incubation facilities can span impressive areas, designed for the optimal growth of the birds. The size of the farm determines the capacity and automation level of these hatcheries. Eggs are placed in specialized incubators with controlled temperature and humidity. A standard incubator can hold anywhere from 500 to 2,500 eggs. If a farm operates several of these units, the total incubation area can cover hundreds of square feet, depending on the farm's needs. Modern incubators often come equipped with automatic egg turning systems, ensuring eggs stay in the proper position throughout the incubation period. These systems also feature sensors to monitor temperature, humidity, and ventilation, key factors for achieving high-quality hatch rates. After 28 days, tiny turkey poults emerge from their shells. Unlike in nature, where they break the shells on their own, humans often assist the process to minimize losses. Once hatched, the poults are transported to grow-out farms. And by the way, their journey is just getting started. When a poult hatches, it's still reliant on residual nutrients from the yolk absorbed in its abdomen. These newborns need warmth because their bodies can't yet maintain the necessary temperature for normal functioning. Right after hatching, poults are placed in warm rooms, set at about 95 degrees Fahrenheit. Over time, the temperature is gradually lowered to 73 degrees, as the poults develop their ability to regulate body heat. Within a few hours or days, the poults begin seeking food and water. Since incubators provide high temperatures and specific conditions for survival, the young turkeys start consuming water and feed actively within the first hours of life. A crucial step after hatching is creating the right environment. This means constant monitoring of temperature and humidity, along with proper conditions to prevent stress or illness caused by inadequate feeding. Right after hatching, poults are moved to specialized facilities where they get the essentials for survival and growth: warmth, feed, water, and protection from disease. These steps are absolutely critical for their healthy development. Transportation to farms happens as soon as the poults are strong enough for the journey. Typically, they're placed in specialized containers designed for their comfort, constant temperature, ventilation, and enough space to move around. These containers, made from either plastic or soft mesh, ensure the poults can breathe and stay safe during transport. The microclimate inside is carefully maintained to keep the poults healthy. Poults are transported to farms within a few hours of hatching, usually before they start eating or drinking. Feeding begins the moment they arrive at the farm, marking a vital stage in their growth. During the first few days, poults are given a special starter feed packed with essential vitamins, proteins, minerals, and amino acids to support healthy growth. This feed often includes finely ground grains, flour, and feed additives. Water is available 24 hours a day because hydration is critical for young birds. Ensuring they receive vitamins and antibiotics helps prevent diseases and supports proper growth. Over time, the feed is gradually switched to more complex formulations, including turkey-specific compound feed designed to build muscle mass effectively. turkey's diet consists of grains, protein supplements, vitamins, and minerals. And no hormones. Most countries strictly ban them. Turkeys grow quickly. In 4 to 6 months, they reach an average weight of 15 to 33 pounds, depending on their gender and breed. Massive poultry barns can house thousands of turkeys at a time, equipped with everything they need for comfort: ventilation systems, automatic feeders, and water dispensers. Free range? Forget about it on large farms. Most turkeys spend their entire lives indoors. Why? Because it's easier to monitor their health and prevent diseases that way. When turkeys reach their target weight, they're transported to specialized processing plants. And this is where things get interesting or complicated, depending on your perspective. The birds are loaded into crates, which are then placed onto trucks. Transport usually happens at night or early in the morning to minimize heat stress. While the final destination is the processing plant, ensuring the turkey's well-being at every stage of their journey is crucial. It's not just about the bird's health, but also about economic efficiency, meat quality, and maintaining the producer's reputation. Ethical practices and meeting societal expectations for humane treatment of animals play a significant role here. Let's dive into the details. Even though the plant is the end of the road, the journey there needs to be as humane as possible. This is not just an ethical issue, it's a practical one. Every stage of raising turkeys represents an investment of time, money, and resources. Any significant loss, illness, or injury caused by stress at this point would undermine all the prior effort. Adhering to standards and regulations helps producers avoid scandals or penalties from the government or animal rights groups. Stressed birds often yield lower quality meat, tougher texture, and diminished taste. This directly impacts the producer's reputation. For example, turkeys that experience severe stress before processing can develop a condition called muscle breakdown, which ruins the texture and flavor of the meat. That's why ensuring their comfort until the very end is not only essential for the farmers, but also critical for the final product's quality. Now, we've reached a moment some might prefer to skip. But if you want to understand the entire process, you need to know the truth. Processing at factories isn't for the faint-hearted. Turkeys are stunned using either electrical currents or gas. This is done to minimize stress and pain. The birds are released one by one into designated holding areas or guiding lanes designed for smooth movement toward the stunning zone. These areas are carefully constructed to reduce panic and overcrowding. They often feature smooth surfaces with no sharp edges to prevent injuries. The design ensures that turkeys move in a single direction without pushing or jostling each other. There are two main methods of stunning. In the first, turkeys are guided through a water bath where a mild electrical current is applied. When their heads touch the water, the current stuns them instantly. The second method involves placing them in a sealed chamber where oxygen levels are gradually reduced and gas is introduced. This causes them to lose consciousness without physical pain. In the stunning areas, dim lighting or blue-tinted lights are often used to calm the birds. Factories also reduce noise levels since sudden loud sounds can cause panic. Human contact at this stage is minimized to avoid adding extra stress. After stunning, automated systems handle the slaughter process. The turkeys are then scalded to remove feathers, and later they are either processed into parts or kept whole. Once stunned and slaughtered, the birds are hung upside down on a conveyor belt that moves them through processing zones. The first step is scalding. Turkeys are dipped into large tanks of hot water, typically over 140 degrees Fahrenheit. This process lasts a few minutes and serves two purposes: softening the skin and sanitizing the bird's surface. After scalding, the turkeys are moved into specialized machines called defeatherers or feather removal machines. These machines are rotating drums fitted with flexible rubber fingers. As the birds pass through, the fingers gently strip the feathers off the body. The rubber material ensures the feathers are removed without damaging the skin. Following this mechanical process, any remaining feathers are checked and manually removed if necessary. This step usually targets small feathers that the machine might miss. The collected feathers aren't wasted. They're repurposed as raw materials for various products, including animal feed, fertilizers, and even certain textiles in some cases. Modern poultry plants use fully automated systems, allowing hundreds, sometimes thousands, of birds to be processed per hour. The high speed of the equipment helps preserve meat quality, as overly lengthy processing can negatively affect texture or appearance. The finished meat is packaged in plastic bags or vacuum-sealed containers and prepared for transportation to stores.